Good morning, grade 10. We're on 5.2 unit, and this is all about the Boolean expressions. Boolean means true or false. Remember Boolean data types? Well, whenever you hear Boolean, you know we're talking about true and false statements. And we're talking about if then else statements, if then statements, not else, just if then. So this is how we're going to use decisions in programming. We know that we have Boolean variables that can be true or false, and they're simple Boolean expressions, and we use operators. And basically remember that comparing variables or values of the same data types using comparison operators. Comparison operators are equal sign, greater than sign, less than sign, and so on. Numeric data can only be compared with other numeric data like integers and real, and text data can only be compared with other text data like char, data type, and string. Remember, char is one character, string can be one or many characters. The table below shows our relational operators or comparison operators, and there they are: equal, not equal to is a greater than, less than, greater than sign. That means not equal. Smaller than, small or equal to, greater than or equal to. Those are the ones that you can use in your code. And here's another example. A computer needs to check if your name is simple. Name equals simple. The computer needs to check if a mark is more than 30. Mark greater than 30. So there you have it. That's a variable and a value. That's a variable and that's a value. So simple will obviously have to be in single inverted commas. So here we have an example where we are asking questions about validity. Yes, some code. RA7, RB7, S word is the word 7, C word 2 is a character number, a character 7. 7 in single inverted commas, that's still a char data type. C word is a char, S word 1 is a string. Now, is RA equal to RB? Yes, because they both have the value of 7. Is RB greater than 5? Yes, it is, because it is greater than 5. It's 7. And RA minus RB, will that be equal to 5? No, because they're both the same numbers. RA minus B equals 0, not 5. So that is false, but it is a valid expression. See that yes there? It's valid because we are comparing integers with another integer. So you can make that statement, but the answer will be false. And those two are all valid. Now this one, we're saying RA is equal to S word. That's not valid, we know, because an integer cannot be equal to a string. Nah, there will be an error, and they'll give an error message, incompatible data types. Can we say S word is equal to C word? Can we say a string equals a char? Yes, we can. But of course it will be false because 7 is not equal to 7. The 7 in words is not equal to the number 7, but both of them are in quotes because they're both text, except that C word 2 is a single character and S word 1 is a string, so you can make a string equal to whatever a char is. So activity 5.2 brings us to today's activity. And we'll move on to 5.3 and 5.4 as well. So here we have, determine whether the following statements will return true or false. Give your reason for your answer. So here's a statement. RA is greater than 2. Is that true or false? This is false. So I'm going to type in there false. Why? Because A is actually RA is equal to 2. So it can't be greater than 2. Is RA equal to RB? And that is true. Okay. Is RA greater than or equal to 2? Well, that is true. It's equal to 2. Might not be greater than, but it definitely is equal to 2. So one of those applies, it's still true. RA plus RB, if you add the two together, will they be true? No, it won't be naught. 2 plus 2 is 4. Now the next one, RA div 2 equals RA mod 2. RA is 2. 2 divided by 2 will give us 1. What's the remainder? 0. So that's false, because 2 div 2 equals 1 and 2 mod 2 equals 0. So they won't be equal to each other. 2 div 2 will not be equal to 2 mod 2, because IA is 2. See, we've got here IA equal to 2. I know it said there, and that's a wrong. Those can't be variables. Those are wrong. This is the instructions that we're dealing with here. Is S word 1 not equal to C word 2? That is true, because S word 1 is jolly and C word 2 is the letter A. Is S word 1 greater than C word 2? That is true, because, oh wait, no, yes, because J has a higher number. J has a higher odd number than A. What does odd number mean? The ordinal number of a of any character, or J has a higher number than A. Ordinal number. I call it odd. I just didn't have space to type ordinal. A is a lower ordinal number than the letter J. And that's how you can sort things in your computer from A to Z, because of the numbers that it represents on the computer. In the process sees J as a higher number than the letter A. C word 2, is it equal to A? Yes, it is. Right there. There it is. C word 2 equal A. By the way, these variables, that's all wrong. It's a misprint, obviously. That is what should be there. So they put this all wrong here. They shouldn't have put these words here. So I'm going to just delete that. We're going to just assume the words are as... unfortunately I can't copy and paste this lot, because that is actually what we're dealing with. The variables are there. So just assume it's the same variables, but we're dealing with this data over here. Okay, so that's basically it. You know, I mean, over here you can just say both are equal to 2, and you're going to put your motivation in there. And yes, it is, because it has been set to A. So I don't know what else other motivation I can do here. Just remember that all characters and all keystrokes on the keyboard are represented by numbers, and they all have unique numbers. And the letter A has got a lower number than the letter Z, so it goes up in numbers as it goes up in the alphabet. Right, so if-then statements. So now when we deal with decisions in Delphi, we use if-then statements, okay? So, you have condition true and false, as you saw in the previous thing. This is the syntax: if a condition, then statement. So we are going to do, I'm not going to go through that, because what we're going to do is, over here, we are going to study this flow chart and answer the questions that follow. So 5.3. If box 4 is moved immediately below box 1, where's box 4? There's box 4 there. If it's moved below box 1, will the algorithm work? Well, we don't have it there anymore. Read points and then add 1,000 points over here. Well, what are we doing here with this actual flowchart? Let's first see. Start, read some points. If the points are greater than 2,500, we're going to add 500. Otherwise, we'll add 1,000. Well, it's going to be logically incorrect. The program will still run, but you're adding 1,000 before you find out if the points are greater than 2,500. So that's not going to work. I mean, it's going to be a wrong algorithm. Right, so what will happen if box 3 and box 4 are interchanged, 3 and 4? Well, you'll add 500 here and 1,000 there, and if that's not what the algorithm is supposed to do, then obviously it'll be wrong, but the program will still run, except that you'll have incorrect output. And strangely enough, if your points are greater than 2,500, you get 500 extra points, plus you get your 1,000 points. So, and if you change 3 and 4, then if it's greater than 2,500, then you get plus 1,000, then you also get 500. So those, those people who have less than 2,500 points will only get 500 more. So yeah, it'll happen. Okay. I'm not going to do a trace table. Amend the flowchart display original points as well as the final points. How are we going to do that? Well, you'll take this display points here, you copy it and put it over here after, in this area right here, after read points and before that question asking if the points are greater than 2,500. So we'll just copy this parallelogram, make a copy of it and put it inside between these two, between this parallelogram and the diamond. Remember, parallelograms are for input and display, so we can read and display and then calculate the points and display points again. Okay, that's how you're going to display the original points. Right, now we're going to do Delphi statements, and we will write down conditional statements. Do the following: set S name to John if the value of S surname equals caribou. Okay, so let's do that. I'm going to say if S surname equals caribou, then S name equals John. Now, of course, I forgot to put my colon over here, but take note of the if statement. And by the way, we could just move this. We should actually. It's all one statement, but normally what we do is you put it on a different line. And in fact, how we normally write it is if, then, and then over here we have our assignment statement. So take note of the difference between that. You have an equal sign there, and a colon and an equal sign there. So that is the first one. Must remember that the equal sign for an if statement and a colon equal when we're setting something. We're saying S name equals John. Okay. Here's another one. Set the variable S even odd to even if the value in variable R parameters. If R remained equals 0, then we set S even or odd to even. It's a string. So say if R remainder, take note just an equal sign 0, then we're going to set a string. The string is called S even or odd. S even or odd variable equals, and inverted commas even, semicolon. I forgot to put a semicolon here, didn't I? These are proper Delphi statements. So if R remainder equals 0 without a colon, then we set S even or odd equal to the word even. Now take note, it didn't like me putting even in single inverted commas, so I have to put it in double. It doesn't, Excel is very fussy here. But that's single inverted commas, okay? Right. Double the value in variable R value if the value in R input does not equal to 10. So if R input is not equal to 10, then we're going to double R value. We're going to say R value equals R value times 2. So I'm going to write here if R input is not equal to 10, then we're going to say R value colon equals R value times by star 2 semicolon. Take note of this, the colon equal, colon equal, colon equal, but if you use an equal sign in your if statement, then you have to just use it equal. It's very important. Next one. Set S gender to female if B gender equals true. So that's quite easy. If B gender equals true, then, okay, I may have to format that to the left. If gender equals true, then we're going to, S gender is going to be female. So then S gender colon equal inverted commas female. Right. And semicolon. Of course, this is now going to have to be left aligned. Oh, I could have done that with this one. Didn't have to put 2 single inverted commas there. Right. If I put a colon, a semicolon afterwards, take note of the equal sign here. Take note, true does not have inverted commas around it, because Boolean variables are either true, the word true or false. You do not put inverted commas around that. And then then the equal sign over there in the if statement, there's no colon, because we're not saying that B gender is true. We're testing to see if B gender equals true. We're not actually stipulating that B gender is equal to true. No. We're asking, if B gender equals true, then S gender is equal to female. Then we're setting S gender to female. So there's a difference between the equal sign there and the colon and equal sign in this statement. Increase the value of total by 10 if the variable R total is greater than or equal to 100. So if R total is greater than or equal to 100, then we're going to add 10 to it. That's it. So if R total is greater than or equal to 100, then R total, this is how you add 10 to R total. R total equals the previous R total plus 10. You're just replacing the old R total with the new total, added 10 to it. Wow. Well, just memorize that, guys. Anyway, so there's your greater than and equal sign. And this is how we write the Delphi code. Might not have it in the program right now, but that's how you will write it. And that is it for today. And we'll see you see you tomorrow.